Hello students, the next refining process we are going to discuss is zone refining. Dear students, it is one of the most interesting processes, as well as in this method we can get the metal in its ultra pure form. So that is the speciality of this zone refining process. So in this video we are going to see the principle involved in zone refining and the processing, and it is applied for which kind of metals. So those are the things we are going to discuss from this video. Okay, now let us move on to the video zone refining. Okay, dear students, this method zone refining, it is based on the principle of fractional crystallization. So it is nothing but melting and recrystallization. First we have to melt the impure form of the metal, then when we cool it, it will be converted into its pure form. That is why it's given that this method is based on the principle of fractional crystallization. So this is a very important key point we have to write when we write this question. It is based on what principle? It is based on the principle of fractional crystallization. So what is fractional crystallization? Melting followed by recrystallization. Okay, so here I have placed a flow chart which is showing the process of zone refining. Look at the first box. It's here impure metal. Okay, so what we have to take first, the impure form of the metal is taken in the form of a rod. The impure metal is taken in the form of what? It is taken in the form of a rod, and this impure metal rod is subjected to a very higher temperature to melt the impure rod. Okay, so that is given in the second box, melted. The impure metal rod is melted. Then after melting, it is allowed to solidify. So if we leave it for some time, automatically, because of the lowered temperature, the melted part automatically will become solidified. Now, what is the speciality in this zone refining process is a main thing we have to keep in our mind, that is the impurities, because we are refining crude metal, no? So it will have some impurities. So the impurities always tend to be in the molten zone. Okay, so it prefers to be in the liquid state than in the solid state. So when the heater is moved accordingly, when the heater is moved along the rod, the impurities also moves, and it prefers to be only in the molten zone. So that is the very essential principle followed in zone refining process. Okay, so now let me explain with the help of a diagram of zone refining. Dear students, this is the picture showing the process of zone refining. Look at the picture very clearly. Now this is the impure form, and it is impure metal rod. It is taken in the form of a rod. Okay, and this is the circular heater. Okay, and it is a mobile heater. Mobile in the sense it is a moving heater. It is not a stationary one. It always will be a moving one. Okay, it will be keep moving around this impure metal rod, and it will the process will start from here. Okay, so when the heater is present in this place particularly, the metal rod will melt. Okay, and the impurities will be in the molten zone. Now when the rod moves here, the impurities also will move from here, and the pure metal will be in this place, and it is solidified. Okay, also when the heater is moves along, see here, it is a molten zone, it contains impurities. If the heater is moves further, this will be the molten zone, and here will be the impurities, and so on. Okay, Mama, so this is the diagram which clearly shows the process of zone refining. So what are the things we need for zone refining? We need the impure metal in the form of a rod, and we need a circular heater. When the heater moves along the rod, melting of the metal takes place, and the impurities prefer to be in the molten zone. So in the solid state there will be no impurities, and only the solid material will be broken, and we can have for our further purpose. Okay, so this is the method of zone refining. Now let us read the text. Okay, so this is the processing of zone refining. What is the first point given? The impure metal is taken in the form of a rod. As we have seen in the picture, the impure metal which is purified is taken in the form of a rod. Okay, and this impure metal rod is heated using a mobile induction heater. Here the term mobile represents moving. The heater will be moving along the rod. Okay, then third point, when one end of the rod is heated, the metal melts. Okay, so wherever the metal is heated, what happens in the particular place, the metal melts. Okay, and the heater slowly moves to the other end. Okay, to proceed further, what we are doing, the heater is allowed to move slowly. At that time, as the heater moves, the impurities also will move to the adjacent molten zone. Okay, so wherever the molten zone is, there what will be there? The impurities will be there. Okay, and this process is repeated several times in order to get the ultra purest form of the metal. This heating and solidification process is repeated several times. So at finally, what we will get? We will get the ultra pure form of the metal. And in this method, in this zone refining method, the semiconductors like silicon, germanium, gallium, and so on. So these are the elements can be purified by using what process? By using this zone refining process. Is it clear, students, what we are doing in the zone refining process? First, the impure metal is taken in the form of a rod, and this impure metal rod is attached with a mobile heater. Mobile in the sense moving heater. And when the heater moves slowly, the metal also start melting. And in this case, the impurities tend to remain in the molten zone. When the metal is solidified, in that place there will be no impurities. That is very, very essential. As a heater moves, the impurities also move along with the heater in the molten zone, and this process is repeated several times to get the metal in a very pure form. Finally, we will get the ultra pure metal. Okay, Vama. So with this, zone refining is completed. Then finally, the purification method given is vapor phase method. And as we have seen in the first slide itself, vapor phase method is of two types. One is Mons process, which is employed for the refining of nickel, whereas the other one is Van Arkel method, which is either used for titanium or for zirconium. Okay, so those two are the processes we are going to see now under the heading of vapor phase method. Okay, so here in this flow chart I have shown you the principle of vapor phase method. Okay, the principle of vapor phase method is given in the flow chart. Okay, so what is given in the first box? Impure form of the metal. So first we have to take the impure form of the metal, and it is allowed to react with the suitable reagent. So when we allow the impure form of the metal to react with the suitable reagent, these two combine. This impure form of the metal and the suitable reagent combine, and they form a volatile. Volatile means easily they can be evaporated. So there is a compound which is easily volatile is obtained as a result of the reaction of impure metal with a suitable reagent. Then step 2. In the step 2, what we are doing is, here the decomposition of the volatile compound takes place. So when the volatile compound is decomposed, we will get the pure form of the metal, whereas the impurities will be the left behind one. Is it clear, students? First, what we are doing, the impure form of the metal is allowed to react with a suitable reagent. As a result, we'll get a volatile compound. When the volatile compound is decomposed, we'll get the metal in a very pure form. So this is the principle employed in vapor phase method. And there are two types of vapor phase method. One is Mons process and the one more is Van Arkel method. So that we can see now. Okay, students, this is the processing employed in Mons process of refining of nickel. It involves two steps. In step 1, nickel is allowed to react with carbon monoxide. Okay, so when nickel is allowed to react with carbon monoxide, we obtain a volatile compound that is nickel tetracarbonyl, NiCO 4 times. The name of this compound is nickel tetracarbonyl. It is volatile in nature, and this volatile compound undergoes decomposition. As a result, we will get the nickel in the pure form, whereas the carbon monoxide automatically will be expelled off. Okay, so this is the process called Mons process, which is mainly used for the refining process of nickel. Is it clear? What is step 1? In the step 1, the impure form of the nickel is allowed to react with a reagent. Here what is the reagent used? The reagent used is carbon monoxide, and we get a volatile compound. So what is the volatile compound we obtain? We obtain the volatile compound nickel tetracarbonyl. Okay, and in step 2 the decomposition of the nickel tetracarbonyl takes place. As a result, we get the nickel in a pure form. At the same time, what is expelled off? The carbonyl ligand is expelled off. So this is Mons process. In the same way, Van Arkel's method is also there. Okay, so this is Van Arkel method. Here I have taken the example of refining of titanium. So in step 1, the impure form of the titanium is allowed to react with 2 molecules of iodine, Ti plus 2I2. So 2 molecules of iodine. When they react each other, the product is titanium tetraiodide, Ti I4 is obtained. It is a volatile compound, and in step 2 this volatile compound, this TiI4, is decomposed. By applying heat, this compound is decomposed. As a result, we are getting the titanium in a pure form. At the same time, the iodine will be expelled off. Is it clear, students? So how many methods we have seen in this video? We have seen sound refining process. Then in the vapor phase method, we have seen about Mons process as well as this Van Arkel's method. Okay, students, go through the videos and have a better understanding. Thank you.